All right, let's talk about something that's literally all around us, in our pockets, on our desks, even in the sky above. These invisible ingredients that are quietly powering our entire modern world. Today, we're digging into the hidden elements that make modern life possible and the incredibly high-stakes global race to control them. So, let's start with a bit of a riddle. What could a cutting-edge, multi-million-dollar F-35 fighter jet possibly share with the wireless earbuds you pop in for your morning commute? I mean, one is an incredible piece of military hardware, the other is, well, it's a personal gadget. But if you could strip them both down to their core components, you'd find they are both totally dependent on the exact same remarkable materials. And the answer, believe it or not, is a very special family of 17 elements. They are the secret ingredient in pretty much every piece of advanced technology we rely on today, from our smartphones and EVs to things like missile guidance systems and the giant wind turbines that are supposed to power our future. Yep, we're talking about rare earth elements, or REEs for short. And as you're about to see, they've quietly become one of the most critical and fiercely contested resources on the entire planet. So what in the world are these things? Honestly, the best way to think about them is like a super spice for other metals. On their own, they're not all that special, but you add just a little pinch of them into an alloy, and bam, you suddenly create materials with these insane, almost superpower-like qualities. But what they're really famous for, their number one job, is creating these mind-blowingly powerful, tiny magnets. And these magnets are basically the invisible muscles that make our modern world work, the things that spin, vibrate, and move everything. Okay, so superpowers is a big claim, right? Let's actually dig into what makes these elements such a game changer for our tech, and so absolutely essential for, the way we live now. And this is where it gets really wild. We're not talking about a small improvement here. A rare earth magnet is 10 to 15 times more powerful than a conventional one. That is not just an upgrade, that's a whole different league of magnetic force. And you can see here pretty clearly where all that power is going. I mean, yeah, they're used in a few other things, like catalysts and polishing glass, but look at that massive slice of the pie. It's all about making those incredible magnets. And that's why this matters to you. This crazy combination of extreme strength and tiny size is what makes our modern tech possible. It's what gives you those powerful little speakers in your earbuds. It's even responsible for that super satisfying snap your earbud case makes when it closes. Or the tiny silent motors in your car that adjust your seat. They're everywhere. Okay, so if this stuff is so critical, I mean, the absolute bedrock of modern technology, that begs a huge question. How on earth did one single country manage to get a near total stranglehold on the entire global supply? The crazy thing is, it didn't start this way, not even close. From the 60s all the way through the mid-90s, the United States was the king of rare earths. But then, a decision was made, a strategic choice based on the idea that the mining and refining process was just too environmentally messy, too dirty. And as the US stepped back, China saw a massive strategic opening and went all in. I mean, all in. And make no mistake, this was not an accident. This was a cold, calculated 30-year master plan. First, they identified the huge strategic value. Second, they embraced the dirty work that other countries didn't want. Third, the state just opened the floodgates with support, cheap land, tons of funding, cheap energy. And to seal the deal, they locked down their human talent, building an intellectual fortress around the whole industry. So what's the end result of that 30-year play? Well, it's a level of global control over a vital resource that is, frankly, staggering. Let's just look at the raw numbers. So it all starts at the very beginning, with mining. Right now, China pulls nearly 60% of all rare earths out of the ground. That's a huge share, for sure. But believe it or not, that's the least impressive number. Because the real chokehold, the real power, isn't what happens next, the refining. This is the nasty part of the business, turning raw rock into usable metals using toxic chemicals. It's complex, it's dirty, and here, China controls a whopping 90% of it. And of course, if you control almost all the refining, you're going to control the final product. Over 90% of the world's high-performance rare earth magnets are made in China. They don't just control a piece of the puzzle, they own the entire board, from the dirt in the ground to the device in your hand. When you have that kind of dominance, people start using some pretty intense language. I mean, just read this quote. One analysis put it this way: China has the US in a periodic table chokehold. That really says it all, doesn't it? Now, we have to clear something up real quick. The name rare earths is actually super misleading. These elements are not geologically rare at all. The problem isn't finding them in the Earth's crust. The real rarity is in having the ability to do that incredibly difficult, dirty, and expensive refining that we just talked about. And you can see that right here on the data. Sure, China has the largest reserves, but look at Brazil. Look at Australia. They're sitting on massive deposits too. So again, the bottleneck isn't the rocks in the ground. It's the lack of the huge industrial infrastructure you need to process it all, an infrastructure that China spent decades building. So as you can probably imagine, the rest of the world is waking up to this new reality, and, well, they're scrambling. But trying to build an entire industry from scratch when you're this far behind, that is a monumental uphill battle. I mean, just look at the hurdles here. The US is trying to rebuild its supply chain, but it's starting about 15 years behind schedule. On top of that, the whole process is incredibly carbon intensive, which clashes directly with Western climate goals. Then there's the people problem. One university program in China graduates more mining engineers than the entire United States. And all the while, China is using its Belt and Road Initiative to lock up future resources all over the world. Which really brings us to a huge, provocative final question. We often say that the 20th century was defined by the global race for oil. It's shaped everything. So as we look ahead to a future that's supposed to be powered by green energy, advanced electronics, and AI, you have to ask yourself, is the great power competition of the 21st century going to be all about these invisible but absolutely essential minerals?